Hello, welcome back to another episode of the FRC Robotics 101. My name is Dang from Green Arms Robotics Team 6520. And without further ado, let's just jump into today's episode. We are talking about the brainstorm process in robot making. Imagine you are preparing for a presentation or just planning for daily activities. A well-made robot cannot exist without the through planning and strategizing or brainstorming. So brainstorming in FRC basically means to find yourself as much ideas, options, strategies as possible. The reason for this is to create as many ideas as possible. The more ideas you have now, the more options you can choose from in the later process. Now, there are three different steps for you to efficiently brainstorm for your robots. The first step is the idea creating step. In this step, every member of the team should take part in researching and coming up with their own ideas. Later on, I will bring some of my friends to show you how do we actually do it. The second step is to analyze all of your ideas that you have gathered, find out their pros and their cons, and to find out which one is the most valuable among a range of different mechanisms that you can choose from in the FRC community. Step 3 is to decide on one main plan that you will stick to for the rest of the build season and to make up as many backup plans as possible. The more backup plans you have, the more organized your team is in the future if there shall be any failures that may happen to the main plan. This is what we have got researching for the shooting mechanism in the FRC 2020 game task. In the FRC 2020 game task, the main scoring method is to shoot as many balls as possible up high. The ball is about 17 centimeters in diameter, and through researching on Sheep Delphi and looking back at older and similar FRC games, we have came up with these ideas. Next up, Tang will present about his idea.
Hi, so I'm Tang, and I'm going to be talking about my ideas for the shooting mechanism for the FRC 2020. So how I came up with this idea is basically that when I saw this game, basically I thought it was a reskin of the 2016 FRC game. Both have a big ball that you're going to shoot into a hole up high. So I just took some of the ideas that are commonly shown in the 2016 games. So the first one is the flywheel or the one-wheel shooter. Basically, you just have a big, heavy wheel in the middle that is going to force a ball along a curved path and then shoot out at the end. It's just that simple. Another idea that is often used in the 2016 game was the two-wheel shooter. Basically, you have two wheels side by side, spinning reverse to each other, and that's going to force a ball through the middle and then shoot out at the end. I just got that from doing research on the forums like Sheep Delphi and looking through robot reviews on YouTube, and that's what I got. Those are the things that are often used in similar games. So the next person that is going to be talking about his idea is going to be Huang.
Hi, my name is Huang, and as per usual, I haven't been brainstorming at all. So rather, I have been watching all of the Lord of the Rings trilogy, and this is the fruit of my labor. So I came up with an idea for a catapult. This mechanism has been used for many centuries and will likely be helpful for this kind of task. I think that the design of the catapult is already well known amongst everyone. So just some quick sketch, like arm, there's something hold the ball, and there's the actual ball. you toss it, basically, with some kind of powering mechanism here that gives it torque. So that concludes my idea, and thank you.
It's finally my turn to submit my ideas. Now, the ideas have been created by researching on older or similar games, researching on forums like Sheep Delphi, and even from movies. But my idea, I want it to be made from the sources of the power. Now, let's talk about Tang. Tang uses the source of motors or two wheels pressed together against the ball, which puts a pressure and a velocity on the ball. And Huang used a catapult hand, which is basically a lever to shoot a ball afar. Now, there are various other sources for power. For example, the piston or the spring in like guns. I will use it in my idea. Let's say I have a simple pipe, and I will use a spring as my source of power. Now, down here, I'll basically have a conveyor belt, and on that conveyor belt, I have different hands. Their job will be pulling these springs down and compress them, and the ball will be loaded down. And since they continue to rotate, the hand will release the spring, and a lot of force will be act on the ball, and it will shoot out with a lot of force. Another idea is to use the piston. The same guiding path is implemented on this design. Basically, down here we have a piston, and the ball is loaded in here, and when the piston is extended, the ball will be shot on the other end of the pipe. Now I will move on to the next step and analyze everyone's ideas. Now, let's say we have came up with we have decided to use the single wheel shooter because we see the cons and the pros system and an intake that will work well with this shooter. And here we have prepared for you two mechanisms for the storage and intake that work well with the single wheels. What we have put here is the Wheel of Doom. Now, what is the Wheel of Doom? It may sound cool, but it's just simply a storage system will alternate in size from different FRC games. This will technically the wheel will do storage and contact with a pickup mechanism. It will go up and out this way. It will go up this way. This works well with the single wheel because the single wheel shooter can be loaded from the bottom up. And this Wheel of Doom, it is proven to be very efficient and very reliable. But the downside of it, it is very hard and very, very complex to design. And only experienced teams can design and manufacture one. Or basically, they are a set of rollers, and they will bring the ball up high and input it into the storage. Now, right there, we have designed our main plan that we will try to stick to and try to make a robot that satisfies this chain of mechanism. We have to make backup plans because what if any of these mechanisms fails to design or to work? And I will show you how to make the backup plans. Let's say you are stuck on the Wheel of Doom. As I said, it is very hard to design. So For starters and for new teams or new members or new generation of the team, it is very hard to design one of these. So you have decided to change this mechanism. So you just make a backup plan that starts with the storage system, which is another one. For example, here I use a very simple path system. It's just basically a pipe or two walls that make up a path that leads the ball into the shooter. And this will work specifically well with the double wheel shooter. Here is a complex of the path and the double wheel. The ball will go down this path and go through this arc and come in contact with the double wheel shooter right here and shoot right out at the end of the path. And right here, I have added an additional wheel to not only guide the ball into the shooter, but create an initial velocity, and this will help the double wheel work more consistently, and it will create more power. Working with the storage of the path system, you can use a range of different intakes. You can just use the conveyor belts like in the main plan. It is basically the conveyor belts without the belts, of course. The rollers can only bring the balls up a small height, so keep this in mind. So right there, I have created a main plan and a backup plan. For your team and your plan for the future can be organized, you should make as many backup plans as possible. So that's it for a very long episode of the brainstorm process. In the next episode, we will talk about the very basic of CAD. And I will see you in future episode. Good luck on designing your own robot.